Hello dear friends, so welcome back to my channel. I'm Gerard and I'm here to study math together with you. So differentiation. So we're going to do differentiation for exponential, but before we get into it, we are going to check our skills so that we can work with differentiation. So I will pause it, write the equation because I'm using a book, so just 1 second. Okay, so we have this equation given to us. It's x to the power 6 minus 12x divided by 3 to the power 3x to the power 3. So we have to simplify this, and since we're working with powers, so this will help us later on to uh, work with exponentials, because exponential is in the form of x power e to the power x. Okay, so we need to simplify this, so we can rewrite it as y is equal to 1/3 x to the power 6 times x to the power of minus 3. So till here there's nothing complicated then, and here we have x to the power of minus, I need to erase this. Alright, we erase all this and we continue. We have power 3 here. So what's going to happen? We have 1/3, the powers add up. Here we have 4x minus 2. 1 plus minus 3, we get this, and once we're done, we just do the dy by dx, and we'll get 3 on 3x to the power of 2. This will go out, eliminate each other, so we have 4, and then we have x minus 3 times minus 2. So because usually we do the multiplication first, so we get x squared once again. So we get x squared plus 8x minus 3. So this is the differentiation of this. Just 1 second. Yes, this is the right answer, and we're going to do some other exercises now, still to prepare for the differentiation of exponential. So just one moment. Alright, so we have this new equation, and we have to find the dy by dx. So dy by dx, so we need to simplify this, and we have a product here, we have brackets, so we can rewrite the whole thing by saying that 2x things that we can work out with times 4x to the power of half plus 2x time, we can take out the bracket here. So let me just erase this. Okay, we'll start over again. So I have therefore 8x times 8 to the power half, 1, 2, plus 2x times x to the power of minus half this time. So we have to simplify this. 1 plus half, we'll get 8x to the power of 3 over 2, plus, here we have 2 to the power of, so x, here we have to add up, so 1 plus minus half, so we get minus half. Okay, I come to something, this is equal to y, this is equal to y. I've come to this simplified equation, and now we just have to do the dy by dx, and so if we dy by dx this, we have times 3 to the power of 2, I can write it in a more presentable way. So if I multiply the power by, to 8, I'm going to have 24. Or I can just divide first. I get 4 times 3, that's 12, and x. So this 3 to 2 minus 1, so it's going to be half, and plus I have 2 x to the power half, so this is going to multiply. I will have 1 times x to the power of minus half, because we take 1 out of it. So we almost got to something like this, except that we don't have this high coefficient and we don't have an x here. I mean, not really that, but the coefficient is smaller here. Here it's bigger, but the power is smaller. So let me check if this answer is correct. Just 1 second. Yes, so the answer is indeed correct, and of course the times 1 just goes away, so we end up with this result. Okay, so that was another exercise to prepare for the exponential, the differentiation exponential. So here is another expression, sorry, here is another equation, and we have to rewrite it somehow to find the rate of change of y in respect to x. So I already saw the answer, so I'm going to do it quite fast. Dy by dx is going to give you, first we do what's outside, so we have 6 times minus 1 minus 6, and here we have the power, it's chain rule, we just call this the chain rule, minus 2, and then we do what's inside here, the differentiation is 2, so we end up with minus 12, 2x minus 3 minus 2. We can even make it the final result can look like this. Let me check. Yes, the answer is correct, and we're going to do something else. 8 divided by root, I forgot, so 8 divided by 5x plus 1. So this is the equation we're given, and I think we know what to do now, because we have done something similar just a moment ago. So we have this equation, we just use to get the dy by dx, we use the chain rule. We have 8 times minus half, we get minus 4, 5x plus 1 minus 3 over 2 times 5, so we end up with minus 20 over 5x plus 1 to the power 3 over 2. So that's the final answer. Okay, we are done with this small transformation of equations so that we can easily differentiate them. So we're going to now do some more exercises to still prepare for the differentiation of exponential equation or expression. Just one moment. So we have an equation like this. We can simplify it to find dy by dx. So we can start by working with the powers. We have a common denominator, and so we get 6 divided by 2, we have 3, and we have x, so we have, let's write it here just to be, so here we have no option, we can just write it like it is. So we have a new equation, and we can simplify it. Here we have the power rule, and for no product, no power with product, I think, or product with power, I'm not sure. This is going to be 4 plus half x to the power of minus 2. So we have this new equation, and let's try to find the dy by dx. It's going to be 12, of course, x minus 1, 4 minus 1. It's going to be 3 plus half times minus 2. It's going to give us minus 1. So we can, if we don't want to show this, we can just write minus 1 here. Just one moment. 1 minus 1 here, and here if we differentiate with minus 1, it's going to be this. So the final result should be something like this. This is 3, and here also it's the power 3. 1 second. Yes, it's correct. So this is the correct answer, and let's work with some other examples until we start with exponentials, and we should have no problem at all working with them. Okay, I found another screen to prevent me from always having to pause the video, so this time it's going to be smoother. And so we have y is equal to, we have 4 root of x minus 1. This is in the first bracket, and then we have 2 root of x plus 5. So we have to differentiate this. So what can we do? We can expand this. We can, I guess, expand this. So let me just get rid of what I've just done. And so we will have 4x to the power half times 2x to the power of half plus 4x to the power of half times 5. Yeah, that's the first part. Plus we have minus 1 times 2x to the power of half plus minus 1 times 5. And the final thing will be 8x. And when we are multiplying, we are adding, so it's going to be the power of 1. Half plus half is 1 plus 20x. Here only the coefficient changes. Minus 1 times 2 is minus 2, and x is to the power of half minus 5. So I have this new equation, and we can now peacefully do the dy by dx. We'll get 8 here. We'll have 10 here, but here we'll have minus half. And so minus 2 divided by 2 is minus 1, and here it's going to be minus half, and the constant goes away. So the final result should look like this is 10. This is 10. So 8 plus 10 divided by x minus 1 over. So divided by x 3 to the power of minus half, and x to the power of minus half. So this should be the final answer. Just a moment. So all this just to get ready for exponential. Maybe it's not needed, but since since I missed something here, sorry. I missed something while I was copying. No, not this. Just 1 second. Okay, maybe we can even go further here. So 8x to the power minus half plus 10 minus 1 to the power of x minus half. I think that might be then 8x. How to simplify it further? Divided by x to the power of minus half. Of course, this can be simplified, right? And yeah, and this will go away. For me, the answer is 8 for now. If I'm not mistaking heavily, so minus 9. This is 9. Sorry, I don't know what I did here. This is 9. It's not 8. Sorry, minus 9. Oops, just once again. Oh, this should be big. Maybe not that big, but okay, now it's good. And so here we have 8 plus 9 over this. Yeah, now it's perfect. Of course, this is not good, but I can simplify and get this. Let's do something else. Let's do some other exercises. And we have here y is equal to x to the power of 10 minus 2x to the power of 5 plus 10 to 10 times x, 10x, divided by 5x to the power of 5. So this should be easier. So we have 5 here. We want to bring everything up. So maybe we can leave this out for now and just work with the inside with 10 times x to the power 5 minus 2 x5 times x minus 5 plus 10x times x to the power of minus 5. I'm thinking that this can be simplified, of course. So 10 minus 5, it's 5. We have minus 2 here. 5 minus 5 plus minus 5. This is 1. It's 1. No. Yeah, it's 1 because it's 0 here. So 1 is going to be 2, then minus 2 plus 10. 1 minus 5, it's going to be minus 4 then. Okay, I end up with this. And here I missed something. This is not 10, this is x to the power of minus 5. So I have 1/5 x to the power of 5 minus 2 plus 10 divided by 5, that's 2, x to the power of minus 4. I have this new equation, and if we do the dy by dx, we'll get 5 divided by 5, 1, x to the power of minus 4. The constant goes away, and we have 2 times minus 4, it's minus 8, x to the power of minus 5. That's what I have, and I should be able to tell you if this is alright or not. And yeah, that's correct. And let's do another exercise. Just once again, we're kind of losing our time somehow, but since I really need to practice my math and avoid to make some silly mistakes, and really not to be lazy. So we have this equation, we have to differentiate it, and so we have this bracket here, we have this minus here, so it's it's cubic square, I think, root square, cubic root square, and we can rewrite everything, of course. That's what we should do. We have this x half, and in the bracket we can say 6x minus half minus x to the power of, this is interesting, so we have x to the power of 6 to there was minus here, so it's going to be just a second, 3 half, that's going to be half here. Am I mistaking here, or is it correct? I think it's correct. So if we do this, because this time this is just x to the power of 2. Yeah, should be just like that. So we have 1/3 x no, let us just be yeah, 1/3, 6 divided by 3, that gives us 3. So we're not going to write anything else, just 3. So we have x half, x to the power of half times x to the power of minus half. So this plus this gives you 0, so it's going to be 1. So we're just going to be 1 here, times 1. And minus 1/3 x to the power of half times x to the power of 2. And this gives us 3 minus 1/3, whatever we have here. So half times, half plus, sorry, it's going to be half plus 2. So times 2, 4 plus 1, it's 5/2. So x 5/2. This is not what we need. So I think I have this new equation, and if we dy by dx this equation, this will just go away. We have minus, and here we have 5 divided by, what do we have? Oh, we'll just have this times this. Actually, we should not be in minus 1, so minus 2, it's 3/2. This is something going on here. I got something like minus, so it's going to be minus 5/6. and x 3, 2. This looks quite odd, I must say, but that's the answer, and it's correct. So we have done all this, and now find the rate of change of y in respect to x when y is equal to 5 for this. So the dy by dx of this, can we rewrite this? I think we can, if we say that it's minus 1 here. And then we're going to use chain rule. We have 5 times minus 1, 4 minus x, and this is going to be 2 minus 1. So minus 1 minus 1. So minus 1 times minus 1, 1 times 5, 5, and we have 4 minus x to the power of minus 2. This is my answer, and so we're going to have a look here. Yeah, of course we can bring this down here. So, but the answer is correct, and we are going to do something else. So still with equations in fractions, and we have 7 over 2x plus 3, and we need to differentiate. We need to find the rate of change of y in respect to x. We rewrite this as 7 2x plus 3 to the power of minus half this time. So dy by dx, we use chain rule here once again, 7 times minus half, and we have 2x plus 3, so minus it's minus 3 over 2 times what's inside 2, and we end up with this will go away, minus 7, and we have 2x plus 3 minus 3 over 2. If I go according to what I saw before, I mean, if they want to have a positive power, we can bring this down, and so this is minus 7. Yeah, it's good, that's good. Alright, and looks like we don't have any problem here. We can try to increase the pace. Then we have x2 minus 3x. That's, I don't know, just I can't do this in a better way. So I have x to the power of 2 minus 3x plus 7. So I have this, and I think I can rewrite this just by doing an easy transformation. This is not true. This is not true. This is not true. So I have to be careful here. I have to be careful here. I have to take the whole equation as x plus 7 to the power minus 1. I think now it's good, and I can just do the dy by dx by using the chain rule, minus x2 minus 3. I can rewrite the whole equation, minus 2 times 2x minus 3. So it's going to give me 3 minus 2x, yeah, divided by, so whole thing to the power of 2. Looks an interesting answer to me, because yeah, an interesting derivative of this equation. Alright, it's good, and looks like we don't have problems with differentiating such equations. And just for fun, we have y is equal to 4 divided by root square of 5x to the power 5x plus 1 to the power of 3. So of course we should rewrite this, and by writing this we will have 1, we have something like this, minus, and now the derivative is going to be easier. So 4 divided by 2 times minus 6, it's minus 3 is minus 6, sorry, and 5 plus 1, we minus 1, so it's going to be minus 5 over 2 times 5, the inner derivative. We have minus 30, 5x plus 1 minus 5 over 2. Should bring this up here. So minus 2. I can just for the form bring this down as denominator with a positive power. And here I see the answer. They even care about the the form to the power 5. So this can be also a way to represent the answer. Alright, so I think we are ready to look at another step, and that's when you have to find the rate of change, but this time is it something more difficult. I see y is equal to 5 over 4 minus x, so I guess the same old thing now, kind of boring. Minus 5, 4 minus 2 times minus 1, this is 5 divided by 4x. I think we don't have problems here, at least from what I see. Yeah, that's not a problem. Therefore, we don't have problems with such an equation. We're going to get into the differentiation of exponential fraction. So I'll write it here: differentiating the exponential fraction. That's going to be also the title of this video, if I manage to do so. So in chapter 2 we learn about the natural exponential fraction. So this function is the only function whose derivative is the same as the function itself. So we have to remember this. If this is equal to y and we have the y by the x, we get the same thing. And so consider the graph. So if you want to have a look at the graph, this is y is equal to y is equal to ex, and this is the coordinate 0, 1, where it crosses the y axis. And so dy by dx, if you take x here and you have x plus delta x here, x plus delta x, so you get some values here, and this can be written as f x plus delta x, and the other one can be written like that. So the point up there, point down here. I think you understand what I'm saying. So if we want to make dy by dx is a rate of change, we can write it in this form, which is y2 minus y1 divided by x2 minus x1. So we'll have this. I will just remove this and remove all this as well. It's not so. We're just proving why, I guess, the derivative of e to the power x is the same. So delta x, this is dy by dx, right? And since we have this, we have f fraction plus delta x minus fx, and we had the 2 points, which was x, whoops, this looks terrible, so x plus delta x minus x. I'll just put this in brackets. So there is limit here. I see they mentioned that it's like when delta x is small, of course, and so we have this, and so the function is, I will erase here to make some space. So the function is, so we have dy by dx is equal to this x plus delta x minus ex. So we're using this thing, and here we have this going away, we just have delta x. So there is another way to rewrite this, and we can say e times ex times e delta x minus e delta x, sorry, ex. Delta x is here, so we factorize, the common factor is out, and we have e delta x minus 1, close the bracket, and we have this. So now something is going to happen so that we get is equal to the dy by dx, the derivative of ex is equal to f. So how do we do this? Just a moment. What we know is that if let me write this. We know that x tends to 0, delta x, is it so? Delta x tends to 0. So this tends to 0. If we have a very small thing here and small thing here, so this is almost 0. There's going to be 1. 1 minus 1 is 0, almost 0. So it's like times 1 almost. It's not 0. If this is almost 0, this is almost 1, and 1 minus 1 is 0. But it's not going to be minus 1. It's not going to be 0, sorry. That x tends to 0. It's 1, 1 minus 1, 0. I think that's how we got this. We said that from this, okay, delta x tends to 0. This is going to be 1 because anything to the power of 0 is 1. So we'll have 1 minus 1, 0. So this looks like it's going to be 0. But this is 2 something, 2 point blah blah blah. So since it's not 0 but a small value here, so it's going to be 2 minus 1 actually, and then it's going to be 1 times this. It gives you only the thing. So this is how they prove it. And so therefore we can conclude if y is equal to ex, the dy by dx is equal to ex. So what we can also do is say that if we have ekx and the dy by dx is going to be kx. Yes, this is the way to differentiate an exponential. Another way to write it is just dy by dx is equal to, or we can say prime efx. Okay, we have some example because time is going fast. We have e7x, and if we differentiate it, so the dx is going to 7e7x, of course. And if we have e5x minus 4, the d by dx is 5e5, yeah. And if we have ex to the power of 3, the dx is going to be, so it's going to be this differentiate. If we differentiate this, we have this. So we put this in the front times ex to the power of 3. So this is what we should have as an answer. So now you see that we always differentiate this. We have the ddx of this, and then we put it at the front. Okay, so we have been differentiating exponential functions, and we have some other examples. Y is equal to 4e2x. If we differentiate, we have 2 here, 8 2x, and yeah, so the ddx of 2x is just 2, so we know how to do it. But if we have something a little bit more challenging, let's say we have something like this, and we need to differentiate it, we know that we have x to the power half. If we differentiate it, the ddx is going to give, sorry, not this here, but the ddx here, half x minus half here. So that's what's going on here. So if we take this, we multiply by minus half, it's going to be minus x over, sorry, wait a second, it's not going to be x on the top, but at the bottom I need 1 here and x root here, and then we have e. Right, that's correct. And what else? We have y is equal to 3e. So if we differentiate this, this is something you should know. If you have 1/2 as an expression, we differentiate it. It's going to be ln x, I guess. Is it not? I think it's ln x. Or is it when you integrate it? What is differentiation of this? Maybe not this. Maybe that's the integration. I think that's the integration. I'm mistaking. X to the power minus half. So differentiate this. You have minus x to the power of. This is 1. Sorry guys, I'm getting tired here. That's it. So it's going to be dy by dx 3 divided by, so minus, sorry, x to the power 2e. I think we're done here. That's it. That's the correct answer. And differentiating, so it's very easy. But if you differentiate ln x, you will get dy by dx is equal to 1. So it's the inverse I was saying. That's how it is. And this is the natural logarithmic function. So we have been speaking about the exponential function, and now we are also talking about the logarithmic function. And we can quickly do a lot of exercises. We can do them very quickly. So we have, for example, e to x, differentiate this. It's so easy. It's going to be just 2e. I'll write d dx here is equal to 2x. So we're not going to do all these because it's going to waste our time. Let's look at y is equal to e minus 2x. So dy by dx is just simply minus 2e minus 2x. Also very easy. So let's look at something complicated. Really, if we have let's say a sum of something, have e for x minus this. Here also we just go by part, nothing, minus 1 times e minus x. So here also we just go by part, and we'll get there. So it's 4e. This is a dy by dx, by the way. It's 4 here minus e. Yeah. So that's easy. And just for the form, if you have y is equal to e 3x minus 1 to the power of 2, we can use the chain rule, and this time this is going to be 1 and times what is inside, so we'll have 2e 3x. Different the derivative of this. So we have like a little bit more job to do, but 2 times 3 is 6e 3x. That's the derivative. So we time by 6e 3x. And let's get rid of this. Actually, you should not be afraid to show your work, and we can, that's 1, so that's just 1. It's just 1. X minus 1. If it's 3x minus 1, I'm considering to multiply this and to have like 9x to the power 2 minus 12 x to the power of 3x, which will I don't know if this is better or this form is better, but I should have a look at the answers, since this one is somehow more challenging. This is an error. When the time you add 3x times 3x, but they are not times, so you have to add them. We are not multiplying directly, that's wrong, that's not correct, so you have to add them, so it's going to be 6 here. And is it 6x? If you're adding them, it should be 6x, not square. Where is it? That was a mistake, I guess. Let me erase what I have done. I mean, if you multiply them, you will get 24e. Here you have to be careful. Multiply, you add them, so it's 6x minus 12e 3x. That looks better. Yeah, that's the correct answer. Very important, this very important. So I am let's do some more complicated ones again. We have y is equal to 1 plus ex divided by ex. So this looks like a quotient rule to me. And what is ex times ex? We just saw this. We say that it's going to be e2x, I guess. It's going to be e2x. We add up the powers. Yeah, and yeah, let's do. Wait, oi, I didn't want to save this, but let's do something. Let's do this quotient thing. I think it's a quotient rule. Why not? I think we can simplify. What about 1 divided by this plus ex on ex? So now you will tell me why we should have ex on ex, because that's 1, and we have like 1 ex plus 1. If we want to add this up, we should, okay, now we have something like that, and we can put this up plus 1. If we differentiate this, you will have minus 1 times e, and this is gone, so we have minus ex, or minus e over here, something like that. So let's have a look if we have something like that. Minus, yeah, we have something like that here. Okay, yes, so this is done. And something interesting was y is equal to ex plus 2 and ex minus 1. So I think we just have to multiply minus ex plus 2 ex minus 2. So here we can simplify. We have 2x plus ex and minus 2. So if we do the differentiation, dy by dx, we'll get 2e 2x plus ex. So we have this, and we can take this out, I guess, and we'll have like 2ex plus 1 might be the result for this. Let's see if we have something like that. Oops, sorry. Let's get back here. Yeah, we have a result in this form, so which means that it's also correcto. So we have we're not going to go with the natural logarithm, I guess, which is the dy by dx of this is going to give us 1. This, if we have to plot this, this is like that. Parabola is this. Yeah, I think that's the parabola function. And the logarithmic ln, I think it's like that. And this is ln x is 0, I guess. If you put it on, I don't know. I'm thinking about how to prove this, because you need to know your logarithm to get 0. What gives us 0 when we have like ln and lg? lg of lg gives us 10. No, I'm not good at this, so difficult to say. But we have a question here. Find the gradient of the tangent at the curve this. Y is equal to 5e, and the point is p05. So we need to find the gradient at this point, the tangent, the y by the x. So we need to do this. It's 2 times 5, 10 ex, and we need to so if we have this, this is just the line, 0, 5 here, but actually here this is 1, is 0, this is 5, 0, 5, 0.05. That's 0.5, right? When x is equal to 0, we have 1 here. Going to be 5, yeah? So we had a 0.05 precisely. So we want to have the gradient at this point. Is this. And so we have 10 e2 0 going to be 1 here, 10. I think the gradient is 10. Yes, that's correct. The gradient is 10. And number 4, we have find the exact value of the gradient of the tangent to the curve. So we have this function ex minus 6. So if we want to have, and it says that the point is where x is equal to 1, so the gradient is going to be this. We can differentiate this is going to be exactly the same, but here we know that it's half, so we're going to multiply by half, and after that we just minus half here as a power. We'll end up with minus 3 x. This we can bring it down if we want. We can write it. We can write this now with 3 x root if you want. Let's see what kind of answer. Oh yeah, we have the x is equal to 1, so it's going to be e here. It's going to be e here. The value of e is like 2 something, 2 point something, and we have 1, so square root of 1 is 1. It can be 1 plus 1 minus, or 3. I think we have 2 results here. We have e minus 3 and e plus 3, or e plus or minus 3. And but here it says that it's minus 3, because square root of 1 here. No, it's not like this, it's just like 1, and it's e minus 3. Because we know the value of x. It's not as if we're finding x, we're substituting x. That's why we don't say that it's minus or plus. So just as a reminder, me making silly mistakes, of course. But what else? Find the coordinates of the minimum point on the curve wave equation. So here is an interesting problem to solve. So the minimum point of this. So what is the minimum point of this? Minimum point is something like that. If we have y is equal to this, and by analogy, this is the minima. But that's when we know also that, so b square minus divided by 2a minus b square, sorry, minus b square. No, it should not be minus, otherwise it will always be the same. Here we don't have p, so it's 0. So it should be 0 here. Why? Yeah. And how do we find the minima here? That's a good question. Good question is that just one moment, I want. Okay guys, so still here, I know that the dy by the x is going to be 0, I guess. If here it's 0, should be 0 here. The dy by the x is equal to 0. So what is the dy by the x here? Dy by the x is the x minus 1. So ex minus 1 is equal to 0. X is equal to 1. So to get 1, x is equal to 0. And there was a question: find the coordinate of the minimum point of the curve with equation. So if x is 0, y is equal to 1. So let's say that this, yeah, we already knew this, 0, 1. That's a maximum? Is it asymptote here? Is it this? Quite. Which number I'm doing? Number 5. Let's see, number 5. Yeah, wow. Yeah, that's good. Wow, this is good. And one last, because after that I see that it's talking about the natural logarithmic function. So we have 6 here. Find the coordinate of the turning point of the curve. So we have y is equal to 2x minus e2x. Okay, we have this equation, and determine whether this point, find the coordinates of the turning points, whether this point is a maximum or a minimum point. So dy by dx to find the gradient at minima and maxima. We have here 2, it's going to be 2. This goes away, and we have this. This is 2. Yeah, this is 2. Sorry for the. So if dy by the x is equal to 0, so 2 minus 2 e2x is equal to 0. I think 2 is outside. 1 minus e2x is equal to 0, so I can divide both sides by 2. So I'm done with the 2 is equal to 0 minus e2x is equal to minus 1. I multiply by minus 1 on both sides. I'm left with just one moment. Okay guys, I'm back. So this is equal to 0, and to get this equal to 0, so let's have a look at this thing. This is never going to be 0. It's asymptote here. So what to do here? X is going to be like a negative infinity. No, infinity. Infinity, oh, so when you go x infinity, the gradient is like this. So what's the gradient of a vertical point, of a vertical line? So this is 90 degree. When it's like this, it's 0. When it's like here, it's 0. Let me look for the answer. So maximum turning point at 0 minus 1. Because this is not the curve actually. Yes, I understand my mistakes here. I will just erase this. So if we look at this minus 2x, it's not this graph. It's going to be, I guess, you inverse. It's going to be something like that. So if this was 0, 1, this is going to be 0 minus 1. Yeah, and that's what they say. And if this was a maxima, and this is supposed to be a, no, this is a minima, no, this is a maxima, this is a minima, this is a minimum, and this is a maximum. Okay. And how do we know it's a minimum? It's because the y by x is there, but it's a minima because if we take, for example, like 1, if we take 1, so we will have ex. We will have ex 1 e2 1, so it's e to the power of 2. But if we take e2 minus 1, so the 2 should show, like, if I remember, this is like going up and then going down. So this should be negative and this should be positive. So this should be negative and this should be positive. That's how we can tell that it's a maxima. That in this case it's a maxima here. Alright, guys, thank you for watching, and I wish you a good night because it's 2 o'clock in the morning. Have a wonderful day, and if you like if you like this video, give it a thumb up and share it with your friends if you think that it's useful and so on. Alright, cheers, bye.